Since the Earth's formation, it has been spinning. Celestial bodies naturally rotate as a result of the gravitational aggregation of rocks and dust that are drifting in space over time as they form celestial bodies. However, once it starts, that rotation never remains consistent. The planet's internal dynamics, such as the rotation of the core and surface winds, as well as external factors like other bodies' gravitational pulls, have an impact on how Earth spins. Earth's rotation around its axis, which determines how long a day is. The Moon, our natural satellite, is by far the most significant force influencing the planet's rotation. Atomic clocks, combined with precise astronomical measurements, have revealed that the length of a day is suddenly getting longer. This has critical impacts not just on our timekeeping but also things like GPS and other technologies that govern our modern life. The slowing of the Earth's rotation has been happening ever since the Moon started orbiting the Earth. A day was just 18.7 hours long, 1.4 billion years ago, in the Neoproterozoic era when the Moon was 27,000 miles closer to Earth then than it is now. While the clocks in our phones indicate there are exactly 24 hours in a day, the actual time it takes for Earth to complete a single rotation varies ever so slightly. These changes occur over periods of millions of years to almost instantly. Even earthquakes and storm events can play a role. It turns out a day is very rarely exactly the magic number of 86,400 seconds. Over millions of years, Earth's rotation has been slowing down due to friction effects associated with the tides driven by the Moon. That process adds about 2.3 milliseconds to the length of each day every century. Over decades and longer, the connection between Earth's interior and surface comes into play, too. Major earthquakes can change the length of the day, although normally by small amounts. For example, the Great Tohoku earthquake of 2011 in Japan, with a magnitude of 8.9, is believed to have sped up Earth's rotation by relatively tiny 1.8 microseconds. According to NASA's estimations, the Three Gorges Dam in China merely delays the rotation of the Earth by 0.06 microseconds. Apart from these large-scale changes, over shorter periods, weather and climate also have important impacts on Earth's rotation, causing variations in both directions. The fortnightly and monthly tidal cycles move mass around the planet, causing changes in the length of day by up to a millisecond in either direction. We can see tidal variations in length of day records over periods as long as 18.6 years. The movement of our atmosphere has a particularly strong effect, and ocean currents also play a role. Seasonal snow cover and rainfall, or groundwater extraction, alter things further. Future impact. What would occur if the Earth's rotation slowed down over a few decades before halting altogether? The length of a year would remain the same, but a day would last a year if the Earth stopped rotating about its axis but kept circling around the Sun with the same inclination. In this hypothetical scenario, the successive absence of centrifugal force would result in a catastrophic change in temperature and severe geologic adjustments to the altering equipotential gravitational condition. The oceans would inevitably move toward the poles if the globe remained still, creating land in the equatorial region. This would eventually lead to the formation of two sizable polar oceans and a massive equatorial megacontinent. If the world were a perfect ellipsoid, the line that separates the regions that hydrologically contribute to each ocean would follow the equator. The topology of the globe, including both the general shape of the world and the contour of the Earth's oceans, is largely influenced by the speed at which the Earth rotates. The physical relief of the Earth only plays a minor role in how ocean boundaries are established. As long as we can envision, the Earth's rotation will continue to slow down for years to come. The geometry of the world is altered and made dynamic by the slowness, which occurs infinitesimally but steadily. The cumulative effect of these dynamic changes is that the globe is becoming resembles a sphere. The gravitational equipotential produces a mean sea level that is a perfect sphere, but it will be billions of years before the globe stops spinning. So there you have it, the facts that cause the slowing down of Earth's rotation. It's amazing to think about how these events can affect our planet's rotation rate and the length of a day. If you have any questions or comments, please leave them down below and I'll be sure to respond. And if you enjoyed this video, please give it a thumbs up and share it with your friends. And don't forget to subscribe and turn on notifications so you never miss a new upload. Thanks for watching. Stay curious.